August 2017. These are the part fours. Or no, part threes, I'm sorry. These are the part threes. 4-point questions. So, we've got a graph -3, 1, -1, 7, 3, 3. Okay, sorry about the lack of a straight edge. Okay, A, B are midpoints of P. So A is the midpoint of PQ. That's what respectively means in order. So A is going to be the midpoint of PQ. All right, let's get that quick. P to Q is 1, 2, 3, 4, 8 by 2. So go 1, 2, 3, 4, 1. That's going to be A. You don't have to write the location, but it's -2, 3. B, looks like it's right there, but let's make sure. 4 there, 4 there. Okay, so 2, 2. Yeah, that's right there. That's B. P, okay. B is going to be at the location 1, 1, 2, 1, 5. All right. Use coordinate geometry. When they say that, it means use the tools of coordinate geometry. Okay? Now, there is a theorem. There is the mid-segment theorem. But this is telling us to use coordinate geometry, not the mid-segment theorem. Okay? The mid-segment theorem is a synthetic geometry application. So when it says use coordinate geometry, here's your tools. You could use slope. There's only 3. Distance or midpoint. Okay? To prove parallel, you're going to use slope. To prove half the length, you're going to use distance. So let's go get them. All right, let's go slopes first. AB. Let's see. It's change in y is 2, change in x is 2, 3, and it's going up, so that's positive. Okay, PR. Same thing, change in y over change in x. Let's go get those numbers. 4 for the change in y. Let's see. So it's 2/3. Okay, so now what I'm going to do is I'm going to make this statement right now. All right, AB is proven parallel to PR because their slopes are equal. We got to get better at that. So we do the calculation right here. Then we tell what that calculation gives us. All right, so I've just proven AB is parallel to PR. Now I got to prove half the length, so I'm going to calculate distances. All right, first for AB, it is going to be 2 squared plus 3 squared equals d squared. That's the change in y and the change in x, using Pythagorean theorem to get the length. That's 13. Take the square root of both sides. So basically we're saying AB has a length that's the square root of 13. I'd rather you didn't use your calculator and get a decimal for that. I don't know if everybody's going to feel the same way or not, whoever's scoring your paper, but PR, same thing. I'm going to use D again, even though I probably shouldn't. It's 52, square root both sides. Okay, so PR is the square root of 52. Now, square root of 52 can break down. Square root of 4 times square root of 13, which is 2 square roots of 13. So PR has a length that's 2 square roots of 13. So that's twice as much as that. Okay, so I'll come over here. AB is half, or has half the length, has half the length of PR, because square root of 13 is half of 2 square roots of 13. Good enough. All right. 33. Okay. BC and AE. Okay. So I've got parallel. Okay, I see it. Right here. Those are right angles. A couple reasons. B is opening up to a diameter. It's an inscribed angle. Its intercepted arc is a semicircle, 180. Half of 180 is 90. So angle B is going to be a right angle. Angle C is a right angle because a tangent and a diameter form a right angle. And then we have these alternate interior angles that we can use. Okay, so it's going to be angle, angle. And then that looks like it's the result of corresponding sides of similar triangles are proportional. So let's go write that up. Okay, first, I would say BC is parallel to ADE because it's given. Okay. What we have, number 2. Oh, okay. So angle BCA is congruent to angle. Let's go with, let's see, CAE. Those alternate interior angles. Are congruent when parallel lines are cut by a transversal. Okay. Next, we should say that EC is tangent because it's given. So angle ECA is a right angle. Because a tangent and a radius to the point of tangency form a right angle. Okay, number 5, angle B is a right angle. And I'm probably taking some shortcuts here, but I think that they'd be reasonable. Angle B is a right angle because it is an inscribed angle. Whose intercepted arc is a semicircle. So I'm going to throw a little bit more in there. Okay, so now the triangles are similar by angle, angle. Not quite. I didn't get the angles congruent. I do need one step. So angle ECA is now congruent to angle B, and that's because all right angles are congruent. And now I can say that the triangles are similar. So triangle ABC is similar to triangle ECA by the angle-angle triangle similarity postulate. Now, those corresponding sides are proportional. And that's because corresponding sides of similar triangles are proportional. Okay, next one, number 34. Okay, pretty good one. First off, there's a couple ways to approach this. It is a square. The way I did it was looking at it like this. I call these X's. So I did it this way. There's plenty of ways to do this, though. I saw students using trig. I saw students do some really nice things. But I'm going to do it this way. So 2x squared equals, let me go find that, 3364. So then we're going to divide by 2 to get x squared equals 1682. Now, I could take the square root of both sides. Now, square root of 1682 is not going to work nice. It's a little over 41. And let's make sure we don't round until the very end. Okay, now the frame, here's a mistake that a lot of students made. They added 4, but it's 4 to both the top and the bottom. So really we should have added 8. So the length of one full side from here to here should be 41.01 plus 8. Okay? So what we're going to do is we're going to take that 41.01 number plus 8. And since we want the area, we're going to do that twice. Okay? So when we do that, so that's your length and that's your width, right? Multiply. When we do that, you get 2402.2, and they wanted the nearest tenth. So now we can round. That's it. Okay, so that was it for that 4-pointer. All right, thanks so much.